Alright, similarity, or similar triangles, or similar shapes. Similar has a technical meaning in mathematics. It's where two shapes are only different in their size, so they are an enlargement of each other. They don't change shape in a colloquial sense, they just get larger or smaller than each other. They shrink or grow in a nice, simple, multiplicative type way. So, if they're not squashed or bent or twisted around, some things will stay the same, while the sizes change. Which means we can easily work out some of these lengths, and we can also slightly trickily work out the other things we need to know. So, if these haven't been squashed or switched, that means that this angle up here must be the same as this angle here, because it hasn't been squashed or squished or twisted or anything weird, it's just grown and shrunk. So this angle A is very straightforwardly 104 degrees. And by the same reasoning, this angle B must be 47 degrees. So it's really important that you remember that as things grow or shrink, they don't open or close their angles if we're just doing a similarity situation. So, what about getting from here to here with the lengths? So similarity, as I mentioned earlier, was multiplicative, which means that 2 times something is 6, because these two lengths are related, so it must be these two that we compare. And we can work that out by doing 6 divided by 2, which we should all know is 3. So that means all the lengths on this shape going that way are 3 times larger, and then for coming back we are dividing by 3. Or you might prefer to say that as timesing by a third, depending where you end up with this math later in time. So to work out length C, we're going to have this 2.5 centimetres that we were given. Use the scale factor, which is 3, to get an answer. 3 times 2.5 is 7.5 centimetres. And then this angle D, this angle, that's a length, isn't it? This length D, well, we had 9 centimetres. We're going to use the 3, but this time we're coming back the other way, so it's not multiplying, it's dividing, which gets us 3 centimetres. So here it was a nice example because the scale factor was a nice integer of 3, made things nice and simple, but this works just as easily with numbers that aren't so simple. So these two rectangles are similar because the question says so, which means that to get from there to there is some multiplication. Now it's not obvious what, I don't know what, but we can easily work it out by doing 135 divided by 28. And if we have our calculator, that will give us an answer. It doesn't simplify that fraction, so that's roughly 4.82. If you want to be really precise with this stuff, you can store that using the store function, and I'm going to store it in alpha A. He says getting it wrong. Let's try that again. 135 divided by 28 is 4 and a bit. Store that in A, and there we go. So that's now stored in A as my number. To get back to F, we're going to do 284 divided by 4.82. Now if you do that using the store function, we can do 284 divided by alpha A, and we get something that's near 58.9 centimetres. Now if I just use this rounded number without the store function, we get something that also rounds to 58.9. They're different in the second decimal place, but they match, so as long as you keep track of your rounding as you go, you'll be pretty close in either way. So this here must be 58.9 centimetres. It doesn't matter how fiddly these numbers are, it's just multiplying and dividing. You've got a calculator for the tricky numbers, and for nice whole numbers you don't even need that. Have fun with this.